In my previous video, I showed an eclipsed sunrise from Australia and asserted that if the observer was on the Terminator line at the bottom dead center of this ball, seeing a refracted moon eclipsing the sun, then according to the heliocentric model, the actual position of the moon had to have been a half a degree or 1 diameter removed from its refracted position, in which case another observer 3,000 miles away would be able to see the actual moon eclipsing the sun at the same time. I based my understanding and therefore my argument on trusted sources like NASA.gov, which says the sun lights half of the Earth and half of the moon. But according to Harry Callahan, Ruhiff, and many other globe proponents, that's not exactly true. So the rebuttal is that our Australian friend wasn't actually at bottom dead center of this globe observing this refracted moon. Instead, the actual position of the moon was here, 2 hours from peak as it was supposed to be, and our Australian friend was observing it via its half a degree of refraction from his actual position of a half a degree beyond bottom dead center, like this. But he wasn't in the dark at the time, because refraction also moves the Terminator line from perfectly bisecting the Earth to a half a degree farther from the sun, which I've obviously exaggerated here to make it easier to see their point. I also understand that in the globe model, the refraction is within our atmosphere, not out in space as I've drawn it, but I couldn't show that as clearly on this scale. The point is that our Australian friend is actually behind the curve of the Earth from the sun and the moon, but refraction displaces the Terminator line and lifts the sun and moon up half a degree so that he can see them together on his horizon despite the Earth being between him and their true positions. Here's Harry Callahan's illustration. You can pause and read it all if you want, but he's basically saying what I just said. He's calling me out for putting the Australian observer on the geometric Terminator line in my illustrations when he's actually at the refracted Terminator line, a half of a degree beyond the geometric Terminator line. Here's Ruhiff's illustration, which shows the same thing, namely that the Australian observer was at the refracted Terminator line, not at the geometric Terminator line as I drew him in my illustrations. But by refracting our observer to the backside of the ball, you've used up every ounce of your refraction lift just to accommodate our Aussie observer seeing the moon on the horizon with the sun when the moon is over 2 hours removed from peak new. How then are you going to accommodate an observer seeing this phenomenon when the moon is only an hour removed from peak new? Because by refracting our observer around the ball, you've effectively nullified any moon refraction lift. See, I can place the observer at the bottom dead center and say that refraction lift doesn't exist, and that'll allow our Australian observer to see the moon on the horizon with the sun about 2 hours from peak new, right? And you can refract the observer around the back of the ball a half a degree, and then refract the moon up a half a degree, and that'll still allow our observer to see the moon on the horizon with the sun about 2 hours from peak new, right? So you haven't gained anything by refracting the observer to the backside of the ball. Instead, you've now lost the ability to account for this footage, where the sun and moon were on the horizon less than an hour removed from peak new. Notice that the moon actually sets a minute after the sun sets. Yet, if the Terminator line is refracted a half a degree beyond bottom dead center, as Harry and Ruhiff say, then that moon had to have completely set before the leading edge of the sun even touched the horizon. Remember that the Australian eclipse had the sun and moon rising 2 hours and 6 minutes removed from peak new moon, while this Florida eclipse has them setting only 58 minutes removed, and both locations are approximately 25 degrees from the equator. So if our observer truly is a half a degree beyond bottom dead center, then it makes perfect sense that he could see the refracted moon on the horizon with the sun 2 hours and 8 minutes from peak new position. But then he no longer has any way to see the moon on the horizon with the sun when it's only 58 minutes from peak new position, because he'd have to see through the Earth to do it. I realize that this stuff is hard to wrap your mind around, But it really all boils down to you can't have it both ways. Look, when Ruhif was saying that the moon would have to be a minimum of 54 minutes from peak new before it could be on the horizon along with the sun, he was obviously assuming that our Terminator line observer was at the bottom dead center of the Earth. But then I posted the Australian eclipse where the observer saw the sun and moon barely peeking up over his horizon a full 2 hours and 8 minutes from peak new, and they realized that this can't work in their model if they add the half a degree of refraction lift. Because if we add that half a degree, our Terminator line observer would have seen that eclipse completely above his horizon instead of just the leading edges of the sun and moon barely peeking up over it. This is Harry's diagram confirming, via stellarium, that without refraction, our Aussie observer, had he been at bottom dead center, would have seen what his video shows him seeing, and that with refraction, he would have instead been seeing his eclipse above the horizon. Naturally, Harry can't very well reject the half a degree of moon refraction lift because his model absolutely depends on it. So instead, he nullified that half a degree by simply moving the observer and the Terminator line itself around the Earth a half a degree from bottom dead center. That way he can keep his moon refraction and account for our Aussie friend seeing the sun and moon barely peeking up over the horizon when the moon was 2 hours and 8 minutes removed from peak new position. But once we refract the Terminator guy to the back of the ball, this pink arrow becomes his horizon line. So if the actual moon was only an hour from peak instead of 2 hours, he wouldn't be able to see it, even in its refracted position. And what if the moon was at the very moment of peak new? Could it possibly be on refracted Terminator guy's horizon along with the sun then? Well, according to Harry, Huberto, Ruhif, and the other globe proponents, not a chance. Remember that these are the very guys who said it would have to be a minimum of 54 minutes from peak new, even adding refraction and dip angle, before it could be on the horizon along with the sun, right? So then what is this? Well, it's the moon at the precise moment of peak new on the horizon with the sun. I have the refraction turned on so I don't have to deal with any buts about that, even though refraction lift supposedly affects the sun and moon equally. Unfortunately, having the refraction turned on in stellarium makes it hard to actually see the moon, so here's a zoomed out shot a few minutes earlier, just so you can see it. Notice that the location is only 12 degrees from the equator, so that should eliminate any buts about the observer looking over a smaller circumference towards the top or bottom of the ball. So naturally, the next diversion will be that the sun and moon aren't aligned in this example. Well, in their model, that's because the orbit of the moon has a 5-degree inclination and doesn't align with the sun and cause an eclipse every month. In fact, I showed this NASA video in an earlier episode to explain their argument. They're about to turn the Earth on its side to show that sometimes the moon passes above the line between center Earth and center sun, and sometimes it passes below that line. In their model, a solar eclipse requires the moon to pass right through that line. But the alleged inclination of the moon will only slide it right or left on stellarium guy's horizon. It will not make it rise higher or lower in relation to his horizon. Maybe a 3D example will work better here. Here's the Earth on its side. Here's the equator. We're going to put the sun over here, straight over here. All right. All that NASA video is saying is if the moon orbited directly along the equator in a perfect circle, then every full moon we'd have a lunar eclipse. Every new moon we'd have a solar eclipse. Okay? They're saying it doesn't go right along the equator. Instead, it's got a tilt to its orbit for some unexplained reason. And sometimes it will be crossing this way. So when it's peak full, it's not between, or it's not on the other side of the Earth from the sun. It's a little off to the side. And sometimes it'll be crossing this way, so when it gets to peak new, right here, it's not directly between the Earth and the sun. It's a little off to the side. Okay, so all I'm saying is this inclination. This would be a positive inclination, negative inclination, zero inclination. Zero inclination is directly between the moon and the sun, therefore a solar eclipse. All right, if we have a negative inclination, then the guy looking out at his horizon, if he could see the new moon, he would see it a little bit left to the sun. And a positive inclination, he'll see it a little bit right to the sun. The moon in that stellarium example that I showed has a negative inclination. Therefore, the guy's seeing it on his horizon a little bit left to the sun, not straight out at the sun. Here would be the sun, he's seeing a little bit left to the sun. My point is, it doesn't matter on the inclination because that's just moving it right to left on his horizon. It's not, the inclination is not making it be a little bit higher or lower, you know, above or below his horizon. It's only sliding it left to right. It's still on his horizon at the time it gets to the peak new position. And that is what I'm saying is impossible. And here's why. Because our guy is actually standing on the side of this ball, looking at the sunset. And the moon, this is his horizon. He can't see below this pizza pan. He can only see on it and everything above it. So as the moon is setting for him, right about here is 2 hours. This would be the peak new position down here centered with the side of the Earth. That would be the peak new. All right, this would be about an hour from peak new. This would be about 2 hours from peak new. So at 2 hours from peak new, then he would be able to see it in their model without refraction. Now with refraction, this moon would actually be up here, 1 moon diameter. So the guy in Australia would have seen it up in his sky like Harry Callahan showed on Stellarium. All right, so to avoid that, him seeing it up in his sky, when we actually have footage of him seeing it barely peeking up over his horizon, Harry and Ruhif have just tilted the Terminator line to here. So now here's the actual moon, here's the refracted moon, so now he can see it on his horizon 2 hours from peak new. And what I'm saying is, what about the Florida footage then? Because now we've got the horizon tilted this way because it's refracted around the back of the ball. So then when we only get to an hour from peak new position, he can no longer see it. The moon is below his horizon. He cannot see it on his horizon with the sun. And then in the stellarium instance, the moon is actually at the moment of peak new. Now granted, it's slid a little sideways, not up and down. It's inclined a little to the left over here instead of straight in line with the sun, but it's still on his horizon, or it's on his horizon in stellarium. And that's impossible because he cannot see below this pizza pan. It would have to be 2 hours from peak before you could see it. And that's what tilting their horizon, that's where it hurt them, because before they were saying, well, we got this horizon, so even an hour from peak new, if we add a little refraction to it, he can see it an hour from peak new. But then if we see it 2 hours from peak new, it's up here in the sky. Well, that doesn't match the observation. So we got to tilt the horizon. Now it matches that observation, but now we've got Florida. You can't see it anymore. Yet we've got the Florida observation of the guy seeing it. And then the stellarium, it's way down here. And we've got the stellarium example of the moon being on the horizon perfectly with the sun at the precise moment of peak new. Again, it doesn't matter left to right of the sun, all right, because that's just sliding it sideways, all right? That's not doing anything to lift it up or down. So you see how it can't work? And what I'm saying is you can't have it both ways, or in this case, you can't have it all three ways. You can't say, yes, we can see it at peak new, yes, we can see it at an hour from peak, And yes, we can see it 2 hours from peak. It can't be all of them. I hope my 3D illustration, although rather clumsy, helped everyone to understand that the alleged inclination of the moon's orbit, noted here as ecliptical latitude, is only going to move the moon right or left on this observer's horizon. It won't raise the moon up or down in relation to his horizon. And so this stellarium example brings this whole angle series full circle. Because here we have an example from software that is supposed to be a perfect representation of the heliocentric model, where the sun and moon are on the horizon together a mere 12 degrees from the equator at the precise moment of peak new. And over a year ago, I published a simple 5-minute video highlighting quotes from a couple university astronomy departments saying that the new moon rises and sets with the sun, and pointed out that the mere angles to the sun versus the moon, which we're told is 400 times closer, make this impossible. Because putting aside the nonsensical notion that we could see around a ball at all, if the extent to which we could see around it was such that we could see the sun rising or setting on our horizon, then the new moon would be below it. And if we could see around the ball all the way to the new moon, then the sun would be above our horizon. Of course, I was met with arguments that these universities either didn't know what they were talking about or that they were speaking generally, and certainly didn't mean that the peak new moon actually rises or sets with the sun, because that would be absurd, right? The moon would have to be a minimum of 54 minutes from peak new before it could be on the horizon along with the sun, right? Yet here we are, 1 year and 5 hours of videos later, looking at the moon perfectly on the horizon with the sun, only 12 degrees from the equator, and at the precise moment of peak new. So just to refresh, we know that our Aussie observer saw the sun and moon barely peeking up over his horizon 2 hours and 8 minutes from peak new. We also know that if we add the half a degree of alleged refraction lift to the moon, our Aussie friend would have instead seen the sun and moon above his horizon. So to fix this problem, the globe proponents have claimed that refraction displaces the Terminator line itself about a half a degree beyond top dead center of the ball. This claim is, of course, made without any observational evidence to support it, which is perfectly in line with the heliocentric mantra, who needs evidence when we can just make up stuff that the cattle can't possibly falsify. We also know that once we've accepted this refracted Terminator line claim, this pink arrow becomes every Terminator guy's horizon line from here on out. Yet we know that Florida Terminator guy observed this sun and moon on his horizon together when the moon was only 56 minutes from peak new. And we realized that this would be impossible with our new pink arrow horizon line. So just comparing these two actual observations is enough to cast serious doubt on their model. But this third simulated observation is the nail in the coffin, because we know for a fact that it's geometrically impossible for the sun and peak new moon to be on the horizon together at 12 degrees from the equator in their model. And now that their half a degree of Terminator line refraction cancels out their half a degree of moon refraction lift, it becomes a matter of simple geometry, right? Because if the observer is at top dead center, he cannot geometrically see the peak new moon in its actual position. NASA even acknowledges that this is geometrically impossible and appeals to refraction to solve the problem. But if we add a half a degree of moon refraction lift and a half a degree of Terminator line refraction displacement, we end up with the same exact geometric angle that NASA, Ruhiff, Harry Callahan, and everyone in the world acknowledges as impossible. In fact, we end up with a model in which the moon truly would have to be a minimum of 2 hours from peak new before it could be seen on the horizon along with the sun, which would make this Florida footage, and especially this stellarium example, nothing short of impossible. So hopefully everyone with an open mind can see that even allowing for refraction lift, the heliocentric model doesn't appear to work. And without refraction lift, even NASA admits that it doesn't work. So I've been working on falsifying this completely unsubstantiated refraction lift claim with observational evidence. But this video is already so long that I'll start getting into my test ideas and some preliminary results in a future video. Thanks for watching.